Alright guys, welcome to lesson 9. In this section, we're going to change topics a little bit and talk about the basics of functions and their graphs. Alright, so let's get started. A relation is a set of ordered pairs. A function is a relation in which, for each distinct value of the first correspondent of the ordered pairs, there's exactly one value of the second correspondent. Meaning, alright, we got ordered pairs. Ordered pairs are made of x's and y's. If my x's don't repeat, then I have a function. If my x's do repeat, every one of them is a relation. A set of ordered pairs is a relation. But if my set doesn't repeat x's, then it is a function. Okay, so let's look at number 1. We got -4, we got -3 and 3. So since my x's don't repeat, this is a function. All right, on number 2, I got 2, 3, 4, and 5. None of my x's repeat, so this is also a function. All right. On 3, you got -4, 0, 2, -4. So since I got -4 twice, this is not a function. Not a function. Okay. Now, domain and range. Domain is a set of all the x's. Range is a set of all the y's. So let's make a list. So my domain here is -4. I'm going to put this in set notation. So I got -4, -1, 1, and 3. My range is all the corresponding y's. So I got -2, 0, 2, and 5. Now you can put them in numerical order, or you can pair them up like I did here. All right, -4 and -2 were in the parentheses together. So you can do that, but that's your answer. You're just making a list of your x's and a list of your y's. Now, all these things can be represented in different ways. So we had a list of ordered pairs on number 4. Here we have what we call a concept map or mapping. All right, so for my domain is everything in the blue bubble. So I got 4, 6, 7, and -3. My range is everything in the red bubble. Notice that I have one less in the red bubble than I do the blue bubble. And that's because 6 and 7 both go to 200. So the y's repeat. I don't care if the y's repeat when I'm looking for a function. When I'm looking for a function, I only care if the x's repeat, not the y's. All right, and then like on number 6, my x's change, but my y's repeat. So my domain is everything on the left side, -5, 0, and 5. And my range is everything on the right side. And I don't have to write it more than once. It's just 2. It never changes. Okay? Now, how do you do this from a graph? Well, on 7, we just have a list of points. So I got -1. Just going from left to right, -1, 0, 1, and 4. So my blue numbers are the domain because they're my x's, and my range is the red numbers, which is my y's. So I got 1, -1, 2, and -3. Again, you can put them in order, or you can just put them in there. It doesn't really matter, as long as they're all there. Now, 8 is tricky. The oval is solid. And so I want to know how much of this, where's this graph touching? So my domain, it goes from -4 to 4 and everything in between. Okay, so you got -4 less than or equal to x less than or equal to +4. And then my range goes from -6 to 6 and everything in between. So I got -6 less than or equal to y, because my range is my y's, less than or equal to +6. So like I said, it's a little tricky, but that's what it is. All right, and then 9, you're dealing with a straight line, and a straight line is special because both the domain and the range are all real numbers. All right, because if you notice that it has arrows on both ends, so this graph goes on forever in both directions, and so it will touch every x and every y as it's extended. okay? Now, 10 is a little tricky because the domain, if you take it goes forever to the left and forever to the right. So my domain is all real numbers. There's no breaks, no holes or anything like that, so it's all real numbers. Now, the problem is my range bottoms out. All right, so my lowest value here is -3, and then it goes up from there. All right, so I got y is greater than or equal to -3. All right, so my domain is from left to right when looking at a graph. My range is from bottom up, from low to high. Okay, so that's that. Now, we can also check a graph to see whether or not something is a function. So I have the same graphs repeated again for 11 through 12, and we're going to use what they call the vertical line test. And this says, if I move my pencil, if I place it vertically on my graph, and I shift it from left to right, do I ever hit the 2 points at the same time? Well, on this first one, number 11, no, I don't. And if I don't, then it's a function. Because if I hit 2 points at the same time, that means my x's are repeating. So number 11 is a function. On 12, you can see that I have x's repeating because my vertical line hits 2 points at the same time. So that's not a function. All right? Straight lines are always a function. So 13 is a function. All right? And then 14, the parabola is also a function because the x's don't repeat. So function. Now, if that parabola was on its side, it's a different problem altogether. Okay, so if you're well versed in this stuff, you can identify your whether or not it's a function, your domains and ranges, all based off the equation. All right, so for number 15, y equals 2x minus 5 is a straight line. And as I said a while ago, a straight line is always a function. And as we said earlier, the domain and range are always all real numbers. All right, 16, you got y equals x squared plus 3. That is a parabola. All right, and a parabola wants to sit, the basic version sits at the vertex, at the origin. So if this is plus 3, that means that is sitting up 3. All right, so let's use that as a guide. So it is a function, we know that. My domain, because it's a parabola, is all real numbers. My range is from low to high. My lowest point is at positive 3. So this is going to be y is greater than or equal to positive 3. All right? You could also write that in interval notation instead of set notation. And if you did that, that would be 3 to infinity. Like so. Now, this is an absolute value graph, but because it's x equals the absolute value of y, it looks like this. Okay, so the absolute value is on its side. Okay, and because it's on its side, the vertical line test fails, and so this is not a function. And because it's on its side, my range is all real numbers. And my domain is from left to right. The lowest point on the left is 0. So I got 0 to infinity. Like so. All right, so not a function. All right. Now let's talk about function notation. When a function's f is defined with a rule or an equation using x and y for the independent variable or independent dependent variables, we say that y is a function of x. To emphasize that y depends on x, we use the notation y equals f of x, called function notation, to express this and read it as f of x, or f at x. Okay, the letter f is a given name of the function, and so you can use any of the 26 letters of the alphabet to do this. So whatever x is in parentheses and whatever is in parentheses, like on 18, 19, 20, whatever is in parentheses, you plug it in for x. So that's what we're going to do on these. So here, I'm plugging in -3, and so that means I got negative 3 squared minus 6 times -3 plus 4. And you can use your calculator to find that this is positive 13 as an answer. Now, if I'm plugging in a number, you should expect the number out. On 19, I'd change x for r, and so all I'm doing is rewriting this with r. So this is going to be negative r squared minus 6r plus 4. Now, you'll notice in the instructions it gives you f and g. So on 20, it says g of r plus 2. So and the f and g tell me which function to look for. On 20, I'm going to use g. And so this is g of r plus 2 equals 3x plus 1. So I got 3 times r plus 2 plus 1. Okay, so distribute and clean this up. So I got 3r plus 6 plus 1 equals 3r plus 7. Okay. Now, another thing we could do with this is that on 21 through 24, we have different scenarios that we're looking at. Well, for each one, we're going to find f of 3. Okay, so for 21, I want to find f of 3, and I'm going to do that by plugging it in. All right, 9 minus 7 is 2. And so for 21, when x is 3, y is 2. All right, on 22, I want to know what f of 3 is. So when is x? When x is 3, y is 1. So you just find it in the list. For 23, I'm looking at the map. I want to know what f of 3 is. When x is 3, what is y? Well, 3 matches with 5. So on 23, my answer is 5. Now, the one that students probably struggle with the most is a graph. Again, I'm looking for f of 3. So when x is 3, so here's x is 3, I follow it up and find the graph, and that means y is 4. All right, so when x is 3, y is 4 on this graph. Okay? Now, we can identify x and y intercepts of a graph. So let's take a look and see where it crosses each axis. So I got an intercept here, 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 and here. And so my x-intercepts are at -3, across the x-axis at -3, -1, and +2. My y-intercepts across the y-axis at -6. Okay? And that's all there is to it. All right, that's it for this lesson. I'll see you in the next one.